Who's going to speak to us about Google Mars. I want to tell you a little bit about Ross's background. We are lucky to have him here speaking today, even though he is a principal investigator at SETI. Ross received his bachelor's in astronomy from the University of Illinois, and also a bachelor's in physics from the same place. And then he received a PhD in planetary science in 2004 from the University of Arizona. And currently, as I mentioned, he's a PI here at the Carl Sagan Center in the SETI Institute, and he works on the Space Sciences and Astrobiology Division
and see what we find,
in the Planetary Systems branch over at NASA Ames. And he's also a research fellow with the Center for the Origin, Dynamics, and Evolution of Planets over at UC Santa Cruz. Ross's work focuses on planetary surface processes, and he's modeled diaperism on Mars, and he spends a lot of his time analyzing surface topography, among other things, to aid in landing site selection for future Mars missions, and also just to give us a better understanding of the geologic history of the red planet.
All right. So my apologies. Let me try and get these fired up here while I talk at the same time, which is probably a recipe for disaster. So let me begin by apologizing for my kind of gruff voice. I'm recovering from a cold. I assure you that I sound worse than I feel, which is better than the inverse. I felt much worse than I sounded the last couple of days. Let me also admit that this is kind of a strange talk. It's a strange talk for me as a publicly funded planetary scientist to be telling you about what is essentially a new software product by a for-profit commercial entity. But I hope that by the end of this talk, you'll realize why those two have gone together, and maybe you will realize that it's not quite so odd. For me, this process that resulted in the Mars mode in Google Earth started about 10 years ago, actually, in 1998, when I was a new graduate student at the University of Arizona. And I showed up for my first semester at work from my thesis advisor, Alfred McEwen, and I wanted a project. I was new. I knew nothing. He had to give me something to do. And what he did is, that time, the Mars Global Surveyor spacecraft had just gone into orbit around Mars. Alfred was a PI, or not a PI, but a team member on the mock camera. And he said, Ross, we need to know where these images are on the planet. I said, okay. So what I want you to do, I have this spreadsheet with centers for these, and here's a large paper map of Mars. You go into the map room, and you mark down on that paper map where the images are that we took. I said, okay. I was a new graduate student. And the answer is that I did that for a couple weeks before I got crazy about it and went off and to do other things, which included trying to write some software to do that automatically. We'll jump forward to a few years ago when NASA, Ames, and Google Incorporated really began to sign their first kind of memorandum of understanding and enabled a cooperative agreement between the two entities. Now, unlike cooperative agreements that the SETI Institute has with NASA Ames, which allow NASA money to flow to SETI, this cooperative agreement actually allowed money from Google to flow to NASA. So Google actually funded projects at Ames, a variety of projects, not just the project that I'm going to talk about, which is called Planetary Content, but there are also terrestrial applications. There's a disaster response project. There are other kinds of things, other projects that Google is funding at NASA. And the reason why that is happening, I can't really admit that I know why, the complete story of why that is happening, but Google thinks that NASA is cool and that space is cool, and they also recognize that there's some talent that Ames has and people at SETI have that Google doesn't have and doesn't want to own, right? So it would be ridiculous for Google to employ a full-time planetary scientist. So that's why that kind of is happening. And so the very first project that we worked on was a project called Google Moon. Now, you may know that through the Maps interface, there used to be if you type moon.google.com, you'll go to this web page. And what this is just using the Google Maps interface that you may use to find directions to your friend's house or to a pizza place. It's in your web browser, but instead of a map of the Earth back there, this is a map of the Moon. There's also one of these for Mars, although it has less features than this one. And actually, Google Moon here started out as a April Fool's Day joke at Google, and it used to be that if you zoomed all the way into the highest zoom factor, you could see cheese. So part of one of the things that we did last year when we revamped this was to get rid of the cheese at the bottom and add on some additional content. And as you can see here, we have some of the Apollo sites marked. I'll go into some more detail on those in a minute. But one of the things that we did is we added a few different kinds of map types. So we put in a better version of the lunar base map back there. We also added this elevation map, which is bad as far as elevation map data goes, because we just don't really have very good elevation data for the moon, but we will soon, fingers crossed. The Japanese do, but it hasn't really been released in a usable format yet. One of the other things we did is we incorporated some historic charts. So there are a boatload of these historic maps that have been scanned in, not by Google, but by the Lunar and Planetary Institute in Houston. And this is the full scan of the map. And what we did is we just put them in the right place. So you can zoom into this map, and you can read all of its color information and what all the different colors mean. But we lined it up so that if hopefully this will work. If I toggle this charts layer on and off, you will see that the craters here line up with the craters underneath. Let me turn the visible back on, although the elevation is probably a little more useful. But you can see that things line up. And so all of these maps line up. We're very excited about that. And they're both these kind of geologic maps, and there's also this other tab down here is topographic maps, which are these historical maps of the moon right there in place in context. Now, the other thing that we did was we created some more rich content at each of these Apollo landing sites. So if I click on Apollo 11 here and I click on this zoom in, this will zoom us all the way in one quick step rather than having to step through each of the zooms. And at each one of the Apollo landing sites, we have more details. Now, this background map here is actually a hand-drawn chart from the distant past that was scanned in. And what we did on each one of these, some of these have this kind of chart, others have where we actually have better imagery. But each one of these has these different place marks. And what these are is these are, in order, numerically, what they did on the surface when they were there. So the first thing they did was here at number 1, and the last thing they did was, I can't remember what the last one is. And each one of these kind of tells the story. This is all pulled out of kind of primary sources. There's information. You can watch the landing video. You can link out to that, the Apollo Lunar Surface Journal. And all of this we had an intern a few summers ago that gathered all this stuff together, and there's this coherent story. And you can walk through it in order. You can go up here to this next tab and go to number 2 and number 3 and learn about what they did on the moon when they were there in order. Or you can also browse independently of that and say, I want to go to 14. And 14 actually has kind of a street view-like view. There are a lot of panoramas that the astronauts took. And so much like with street views, you can pan around these guys and look. And you can actually see Buzz over there at the lander, and you can zoom in pretty well and see the flags on his backpack. So that's fun. So you can explore a lot of data in this manner for the Apollo sites. So that was kind of last year's project, and that was fun. But it was kind of a hack job and not very enveloping, not very engrossing, we thought. And so we moved forward to the 3D platform that Google has. This is Maps. Google Maps is they refer to internally as the 2D platform, and the 3D platform is Google Earth. So let's take a look at Google Earth. I hope you are familiar with it to some extent. And I didn't undo that. Oh well. So this is Google Earth. It is a reasonably immersive 3D browser for the Earth. It is place-based. And there's all kinds of great stuff you can turn on. Buildings and streets and borders. And there's a lot to explore on Google Earth. And recently, with the release of the new version earlier, about a month ago, they included ocean information, detailed bathymetry information. There's all kinds of stuff on the Earth. I'm not going to talk about it. What I am going to talk about is how we've talked about the other planets in the solar system. Now, one of the first things that we did, one of the problems with Google Earth was it was just the Earth. And like many geographic bits of software that were primarily written for the Earth, going to other planets was something that the original developers just didn't think of. And so getting a planet with a different radius or different topography was something that was a fundamental change inside the client code that had to be made by Google engineers. So while they were trying to figure out how to prioritize that in their giant scheme of doing things, and to do that, we started experimenting with other ways to try and get some data onto the globe, and just trying to experiment with how to present data to people, planetary data. So one of the things that you can do, there are a lot of things you can do in Google Earth, and one of those is you can put in arbitrary photographs overlaid on the surface. And so the first thing we kind of did, we did this with Mars, but I'll show you an IO example just because it's more fun and gives you some variety. So when I turn on this link, this will load up IO. So now you're looking at Google IO. Well, you're not really, of course. What I've just simply done is I've taken a global map of IO and I've wrapped it around the planet in a way that Google Earth can read and understand. And the problem is, of course, is you can go down here and you can turn on, United States, and you can look for the closest pizza joint, and it's not really, you kind of have to make sure that you turn off all of this stuff, and that you turn off the atmosphere, and that you pretend like that little layers panel down there just doesn't exist. But if you do that, you have a reasonable facsimile of another planet right there in your browser. Now the breakdown is you can kind of turn on the tropics of Cancer and stuff, but again, you kind of have to suspend your disbelief. Now what you can do is you can plot data on here just like you do in Google Earth, or you can just roam around here. You can put higher resolution data sets, et cetera. So we did a lot of experimenting, and finally earlier this month, not earlier this month, a month ago, on the 2nd of February, the newest version of Google Earth, which is this one here that I'm working with, got released. And it has a Mars mode. So now if you go up here to this top bar, there's a little Saturn-looking button. And it's a pull-down menu. It used to just be a switch. It took you to sky mode. And now there's a Mars element in there. And I would suggest that you keep your eye on that pull-down. Additional planets may be coming sometime in the future. So let's go to Mars. You can go to Mars, and you get another thing here. And now if we go down here, I closed this layers panel because it was Earth stuff that I didn't want to look at. But when you go to Mars, it's Mars stuff. And there's lots of good stuff in the layers panel for Mars stuff. And this is Mars. And it has lots of fun place marks. And we'll take you on a little tour. One of the other things that Google Earth 5 has is the ability to script tours. So I'm going to start this up, and we'll fly through the tour here. Where's my button? So I'm just going to let this play so I can talk over it and not be doing too many camera controls. So the Mars in Google Earth has the right radius. It has a lot of basic data sets. The global, it has topography, and we'll see some of that. The global data set here, I'll be pausing it in some places. We won't do that. The global data set is essentially Viking data, imagery-wise, with some places of higher resolution HRSC imagery, which is a stereo camera. And again, the global topography is MOLA, which is low resolution laser altimetry data, but locally is higher resolution HRSC data. So you can see that strip down the middle of Olympus Mons there is higher resolution visual and topographic data as we fly around Olympus Mons, the largest volcano in the solar system. All these little dots on the surface are points of interest. You can click on any of them. One of the things that we have included, I have to turn the tour off, is excerpts from Bill Hartman's book, A Traveler's Guide to Mars. That's what all those little green hikers are. And so you can learn more about Olympus Mons or any of the other places where there are a bunch of little green hikers. The other thing we have here is, of course, planetary nomenclature. There are two Olympus Mons. They have different names. There's planetary nomenclature from the USGS, so if you know place names on Mars, if you don't, you can find them out. They're there. And these other little, we'll zoom into them in more detail in a moment. But these other place marks are examples of the kinds of data that we have in Google Earth. So we're just kind of doing a beauty pan around Olympus Mons. But we'll zoom in here. This is actually a Highrise image. Highrise is an imager at Mars right now. It takes 25 centimeter per pixel images. And actually, you can pretty much zoom all the way in. You can see individual lava flows and individual rocks. And a select few of these are pasted down kind of in the base layer in Google Mars. And you can see all of the great lava flows. And it works out really well over the higher resolution topography. And is really, we were pretty impressed by it. We were pretty happy with it. So this is kind of a glory pan of I'll try and speed this up. Faster. Okay, so this is another example of a high-resolution, high-rise image. And actually what we're going to do here is push all the way down. This is a dust avalanche on Mars. And that is an individual boulder. It's about the size of a large delivery truck. And so we're really capturing all the scales from the planetary to as small as we can go. Let's see, so this is just more kind of glory panning around Olympus Mons. The red versus orange. Oh, all right. So the red squares are high-rise images. So these are these burned-in high-rise images. They're in the base layer, and you can get information about them. And each one of them has a little blurb and also links back to the instruments page for that information. So if you click on see this image's observation information page, when you click on that, that actually causes Google Earth to fire up a web browser and takes you to the Highrise web page, which is provided by that science team about their image. And you can read the same comment, the same thing that we have in Google Earth. You can get all the detailed information. You can get the full data products and all kinds of madness. So it's a window back to the original data. The orange ones are CTX imagery, which is the context imager on MRO. And some of these have a load this image. We'll show you that later because there's actually a better version of that. So we'll go ahead and we'll go forward here again. It's not lit at all. In fact, these are from the images themselves had natural lighting when they were taken. So as long as we put them in the right place, they all look reasonable. How they're doing are lit from the west. Yeah, okay. It's always afternoon on Mars. Yeah, because all of our orbiters are always are frequently in afternoon orbits. So we'll go ahead and zoom through Valles Marineris here. We're too fast, that's all right. And just kind of see some more of this. Valles Marineris is beautiful topography. Although I have this scripted, you can go in and explore this to your heart's content. There's lots to look at. And you can see some places, kind of the topography pops in as we go forward. But of course, there are some places here, like this guy here, where this is still this low-resolution topography and imagery, and we really can't do anything about that until we get higher res data in that spot. More glorious high-rise pans, and you can see scarps and stuff that. And yes, please.
Currently, is all the visuals from U.S. NASA?
No, actually. As you can see, the credit line down here at the bottom says ESA DLR. And the HRSC imagery that provides a lot of the best color data. So I'll kind of zoom out here. So this patch right here, kind of it looks crummy. And it's also associated with crummy topography. Well, not really crummy. It's great topography, but in comparison to what we get later, it's always not as well. So this is Viking shading and color with a little bit of mock color thrown in to try and make it match, and MOLA topography. In these places where there's this better looking color, that's HRSC, an HRSC color product, and for the most part, where there's an HRSC color product, there's also HRSC topography underneath it. And so that's European data. So I'll go ahead and load one of these HRSC overlays. So if you click on some of the orange CTX images have a load this image, and if you click on load this image, that image will get loaded in. And you'll see that the high-rise image that was underneath it isn't visible now because that image is on top of it. But that's okay because the CTX image in this area is better. Let's see if I can get my controls right. We'll kind of pan around this layered deposit. So other things that are available in Google Mars, in addition to kind of those basic data sets, so we'll get ourselves north side up. I'll take you on a tour of, so also in here you can say things like, someone shout out their favorite place on Mars. We'll get to that. I'm going to get to that. some other place. I'm trying to demonstrate that you can, I'll say this instead. You're not giving me any good ones. Beyer Crater, for example. So we can go to Beyer Crater. You can type in any names that you know on Mars, and you can go to those areas, and there's Beyer Crater. You can type in maybe some places that, this is one that the Google engineers put in. If you type in pizza, FYI, you also get Beyer Crater. But you can type in face on Mars, you can type in Spirit, you can go to those places. All the nomenclature is there and it's searchable. One of the things, you'll notice that it says Mars Search Test up at the top, and that's because I didn't unload something. There's going to be a new data release, and so you can do a few more things that you can't do now. So in versions of Google Earth that you can have, you can't type in an arbitrary image number, but in a few weeks you will be able to do that. So if you know of a mock image number or a high-rise image number or a CTX image number, you can type it in right there and go to that spot.
What about White Rock? I mean,
White Rock? Well,
it's got a lot of history.
yeah, I think that might work. No, it didn't. But if you know that it's in Pollock Crater.
Does the nomenclature also include some of the more whimsical names that the scientists have attached to individual rocks at landing sites?
Individual rocks at landing sites? No. That's at a granularity that is a little too fine for us right now. But White Rock is a great example. We should totally get White Rock into the search base. Yeah. So search is good and fun. So let's talk about some of the fun spacecraft. So in addition to kind of all these other things, we can turn on the rovers and landers, and there are a lot of them. We have place marks for kind of historical landers, Mars 2, 3, and 6, Viking 1, Viking 2. But of course, the most interesting stuff is going to be Spirit and Opportunity. I think so. And the reason why I say that is because in these places, not only do we have this high-rise imagery, but we also have some high-rise DEM. So the high-rise imager can take 2 images of one spot, and from that stereo pair of imagery, we can build topography. So this topography is actually stereo topography from high-rise at kind of the meter scale. And if you go down here to look at it, you can see that that crater really, keyboard controls, has topography. You can see the Columbia Hills in the distance. I can get my camera controls working. Now what you can see here is actually I'll go back, I had this scripted up here too. We will blow past historical stuff. Viking 1, yeah, great. Pathfinder. Oh, I should stop at Pathfinder. I really should stop at Pathfinder. And I should stop at Pathfinder because, so as you saw in some of the other ones, we have, those rovers have taken panoramas as well. And so you can click on the panoramas, you can say fly into this panorama, and you can actually zoom into this kind of bowl-shaped image. And once it snaps in, that's actually the full panorama. You can explore this again, just like you would in any other thing. You can really zoom in and get as much resolution as the camera actually took. And there's the Spirit rover there against the Yogi rock. And if you look, you'll see a Spirit rover, or not Spirit rover, the Sojourner rover over there against the Yogi rock. And the cool thing is that high-rise actually, you can see that that's a rock that big from orbit. And you can see here that this is the where the Sagan Memorial Station was. So that little rover is in the right place for that panorama. Where did my movie go? Because the movie really shows this much better than I can do. Play. Well, you're pausing. Here we go. So each of these, so like I said, the topography is good, and you can see the topography better in this tour as it plays. And the little red line is the path that the rover took. It first went out there to Bonneville Crater, and each one of those little camera icons is where a panorama is that you can click on and explore. After Bonneville Crater, it set its sights on the Columbia Hills there in the distance. Let me get rid of this because it's really kind of not important. And it was a reasonably long journey to get there. We'll speed it up. Before it started and started its ascent of Husband Hill here. And again, each one of those little camera icons is is a panorama that you can explore, and it took the rover about a year in Earth time to get from the foothills up there to the summit. I don't have really time to show you each one of these panoramas, but they're all excellent, and even those are only a subset of all the panoramas available. We just had to kind of pick and choose which ones to include. But it's really a breathtaking view, and I suggest you go and visit and look around, because you can. You can download this program. You can do exactly this. I'm going to stop, I think, here, because I want to visit this panorama to show you something. I think this is the right one. So we're going to fly into this panorama too. And so one of the many cool things, let's see if I can close the right things. Oh, I got out of it. Drat. Too many button pushes. Get me out. Okay. There we are. Okay. No, I won't touch it. So one of the cool things is that these panoramas, so this is high-rise topography, like I said, very excellent topography, the best topography that we have of the surface. And one of the cool things that you can do, and again, here you can see the rover tracks in this panorama, one of the fun things, one of the many fun things, is that one of the things people don't know about much is there's a little slider over here, and you can change the visibility of the layer that you're on. So I can actually turn the visibility of this panorama down. You can see that it lines up really, really well. And that's actually where we're headed. I can turn this back on, and the hills kind of come back. This may not be very interesting to you, but the people that created this data to make this happen, it's really, really cool. The fact that it just lines up, and we really didn't do anything special. We grabbed the topography from Highrise, we grabbed this panorama from the Mars rover's public website, and more or less stuck them together. We had to do some aligning to get them to fit up, but we didn't do any fancy warping or anything like that. And so just kind of tilt back down for me. It doesn't like tilting down. It's one of the bugs. It doesn't like tilting down when you're below 0. Where are we? So, of course, the rovers, Spirit rover here is at home plate, and there's the Spirit rover model there. And, of course, there's the model for Opportunity, and we can visit Opportunity. Opportunity also has high-rise topography in a small spot just around the crater itself, but that doesn't make it any less stunning. Go into one of these guys. And again, Google Earth really allows you to, putting all the data together in this way really allows you to go from, you know, here's an individual rock on the surface of Mars, you know, there, that's some of the sandstone that they saw in the side of that cliff, right? Those are sandstone layers. Those are individual rocks, probably about the size of your chair or your fist. So, you know, we were pretty happy with how things turned out with Google Mars. For the rover scientists in the audience, you might say, "Oh, that's great, that's fun, you can see this." But what really good is that to me? Well, each one of these little-known Easter egg on the flags that begin each of these traverses, there's a little thing here that says "Load Rover Waypoint Data." And if you click on that, come on, baby, click on that. Oh. One of the great perils of doing live demos. There we go. So when you click on that, all of these little guys get loaded, and each one of these is a waypoint, an actual waypoint in this polygon, and each one of these can be clicked on, and there's a little info bubble there, and you can go, again, you'll leave Google Earth and go out to the website that the MER rovers provide, and so this is information for that day on Mars. These are all the images that they took. You can explore all of this data and find the information that you want, and possibly lots that you don't. But it's all there, and it's all explorable. And the other good thing, the other fun thing, is in addition to kind of these example images, so these red and And it's not just red and blue. It's just that's where most of them were. Let's see. Where do I know that there are blue ones? So we'll go back to Valles Marineris because it'll be faster for me to type than it is for me to try and navigate there with my touchpad. So there are also blue squares, and the blue squares are CRISM spectrometer data, examples of those, and those are those little blue guys. And again, each one of these opens up, and there's a picture of the image and links back to that stuff. But each one of these kind of red and orange and blue boxes are just examples. They're a smattering, just a portion of all the data that you could look at. Because, again, you have to remember that this product is a product for grandma. It's not a product for scientists. Yeah?
What are the little green men?
The little green men are these are the hiker icons for the Traveler's Guide to Mars layers. These are excerpts from the book A Traveler's Guide to Mars by Bill Hartman. Great publicly accessible text. But despite that, you can turn off the featured satellite image with these kind of this smattering of those place marks. And you can go to spacecraft imagery. And here, by default, unchecked. Yeah?
There was one of the rovers showed the dust devil, the animation.
Yes. I think we have one of those pans in there, but we don't have the animation in. And there's a lot of things on our list that you could include. We haven't. So this set of unchecked, if I turn this on, this actually turns on not just some of the high-rise images, but all of the high-rise images. So these are all of the high-rise images in this area as of February 2nd. Now, these aren't all overlaid in the right place. As you can see, these are just polygons. But it can show you, again, each one of these opens up. It has an info bubble. You can go back to the spacecraft website for that observation. And that's true for all of these other data sets, CTX, MACH, HRSC, CRISM. And so it allows you as a scientist to go to an area and say, hey, what's here? What's here? Let me turn on everything, MACH, could bog down everything. But that really allows you to explore and say, what more data is here? What images are here? What can I find, and how can that help me to get started on collecting the information and going on to do my scientific investigation? Now, what I've showed you so far is just data that exists. I should also show you this, because it's also fun. I forgot about this. This isn't in there yet. So as you know, Phoenix, since I was kind of on my spacecraft thing, let me finish that, and I'll go on to the other stuff. So Phoenix, side effect. Let me turn off the Mars gallery. So Phoenix, and the place names. The Phoenix lander landed in the northern plains of Mars. And Highrise took this picture of Heimdall crater, and right as Phoenix was landing. And you can see right here in this blow-up that little white thing is the Phoenix lander on its way down to the ground. And here's a blow-up in the corner. And so that's the Phoenix lander, the descent module there, and that's its parachute. And Highrise took this picture, and Highrise showed this picture, and the problem is the people are like, wow, did it land in that crater? Well, it didn't. And now, with Google Earth, so the Phoenix PI had the hardest time explaining this to people, that no, it didn't land in the crater, it really landed outside of the crater. And now, if I can get this to zoom in the way I want it to, you can see that image is, that the perspective is such that when it was falling down, it was just in the foreground of the crater. There's Heimdall crater back there. And so the image is kind of there floating in space in the right kind of geometric place. Turn that off. We're hoping to get that floating image in the next actual release. Yeah?
So can you do that kind of perspective view for arbitrary images, or was that a special case?
For Highrise?
Yeah.
Can we make arbitrary high slews?
Well, I mean, you showed the perspective, you showed the relative positioning.
Right.
You inserted that frame, and that is something you can do for any image.
Oh, yes. I'm sorry. I thought you were asking. I wear a lot of hats. One of the hats I wear is as a Highrise team member. And if you were asking me, can Highrise roll to very high angle to do things, to take images, the answer is yes, but that is a special case. When you're asking me in the context of Google Earth, can anybody take a picture and put it there and make it float in space, the answer is yes, absolutely. You can put any picture in anywhere. And in fact, people do that on the Earth to show their vacation pictures and stuff like that, where they took it.
I guess I was asking whether it was set. I mean, whether you can, is that something that is just essentially how easy is it to draw? Is it
It's reasonably easy. It's not very easy, but it's not impossible. So I'll talk a little bit more about some of the enabling technologies in a second, assuming I'm not out of time, which I seem to have been running on. So the data that I've been showing you so far is data that comes with Google Earth. But Google Earth actually has a framework that allows you to load data dynamically. You can either load local data, so like I showed you with that I/O map around the planet. That's nothing special. Those are files that are on this laptop that you can tell Google Earth to load. So you can do that with imagery data. You can do that with place mark data. And it doesn't have to just be on your computer. Excuse me. One of the things that you can also do is provide Google Earth with basically a little bookmark that says every time you click on this, when you load this, go out and check this web server for the information. So one of the things that the Highrise team does is we actually provide that kind of information for our imagery. So let me go ahead and turn back on the Highrise data. So again, these are the Highrise footprints that were released on February 2nd when this version of the Google client got released. Of course, Highrise has taken pictures since then, and we've released pictures since then. Highrise releases about 2 or 3 images every week. So if you know where to find us and find that little thing, so I'll go ahead and I do. But it's out there on the internet, and I'm happy to point you to it. You can turn on Highrise footprints that you can get, and I will turn on these Highrise footprints and show you the difference. And the difference is that over here, on this little mesa over here, the default Google Earth doesn't have anything. But the Highrise layer that's live does. And that's because Google Earth is actually going out over the wire and checking a server in Tucson and asking it, where are footprints? And it's drawing them. And every night at 4 a.m., there's a script on the Tucson servers that trolls through the database and puts out new footprints. So you can dynamically add more information to Google Earth if you want to through other external means. And so we do this for the public, and also we actually do this. There's a password-protected version of this that actually has all the data that the Highrise team hasn't released. So the team actually uses this kind of interface as well to find out, is that image where I wanted it to be? Are there new images in this area that haven't been released yet? Where are they? There are other tools that the team can use to do that, but this is one more. And actually, the CRISM team does that as well. Provides that data in a Google Earth kind of format. So other things that you can do in Google Earth are you can also use it to communicate with other scientists. You can say, hey, that's an interesting thing right there. I want to show that to Bob. You can go up here to the top and you can say, add place mark. And you can, the way that you would do that is you move this little guy around and you say, that is an interesting crater right there. I'm going to say, interesting crater. Hopefully this will go in the right place. You say, OK. So now you saved this mark. And it's right here, although it's called untitled place mark. I never understand why it's doing that for me. But you can change that to something short. See, that fixed it. OK, so now it says blah. And you can say, I want to show my colleague Bob that that's an interesting thing. And it's interesting because it's in that spot. And so you can do that. You can, on blah over here in your places menu, you can right-click on it, and you can say, save place as. Say, I want to save this as this .kmz or .kml are the different kind of file formats that this information that Google Earth uses is saved in. You can say save. Now that's a file out on your hard drive. You can email that to your friend Bob and say, hey, open this in Google Earth, and he'll see this exact thing. You can also make polygons. Oops, I need to have it open. Come here. Get info. And now this cursor is a little thing, and I can say, I'm really interested in this area for God knows why, but you want to be able to see through it, so maybe you'll change this to just outlined. Say, OK, great. I'm going to send that to Bob too. You can also make, this is add path. This is just polylines that aren't closed. So you can draw these different shapes on the surface. You can share them with your friends. If you are a data provider, you can also put data on Mars and tell the world where it is and point them to the URL on your servers. For example, a colleague of mine that works on the MSL landing sites went ahead and said, hey, where are all of our potential MSL landing sites? This, of course, was more important a few months ago than it is now, or more pressing. And so you can click on one of these guys, and it'll take you to Eberswalde crater. And look, there is the landing ellipse at the beginning and opening of the launch window. That's why they're in different spots. But you can say, okay, so what high-rise images are here? Those are all the high-rise images that are here, you know. And is this one in? Is it out? Right? And it helps us to say exactly, to communicate, this is where the landing ellipse is. These are the images that are inside of it. In olden days, to do this, it was, you know, someone made a map. You kind of had to look at the map and look at your images and say, were these images inside that ellipse or not? Or you had to use a very expensive package like ArcGIS to really locate these images in this place. So I'm almost out of time, so I'm going to stop there and say that there's a lot of enabling technology underneath this, but it's all really accessible. There's a big community of Earth, Google Earth people that do this stuff for Earth. You can add arbitrary place marks. You can, as I said, you can send individual files to friends and colleagues. There's a lot of power here, and we're hoping that although this information is static, you know, like I said, the high-res images aren't updated in the default version, that we're going to try and get more kind of live data feeds wired into this, so that, you know, you'll be able to open up Google Earth and see where the rover was yesterday, or, you know, what images were taken last week, and make it more dynamic. So I'm happy to take any and all of your questions now, and until however much time we have, and feel free to ask me questions afterwards as well if we run out of time. Yeah.
Was there an administrative problem in determining Greenwich, longitude 0?
Right, so how do we define the longitude system on Mars? Fortunately, that is a problem that has been taken care of by people far before our time, well, before mine. And there's a crater, I think it's called Area 0, and someone just said, that's it, that's 0. And so that's how it was originally defined. Its location of where the exact 0 meridian is has moved a little bit over the years as we've gotten better geodetic data for the whole planet. But that amounts to kind of small map corrections. But it's still in the vicinity of the Area 0 crater. But yeah, it was essentially an arbitrary definition. That's right. He asked where it was, so we'll type in Area. It says Area crater or Area 0. Let's go to Area 0. I guess I could have just turned on the Latin long lines and gone to 0 as well, but there it is. That's Area 0. Whoa, too far, too far. That's not, wow, not too far. So that's Area 0. That's Area crater right there. And that crater, and of course back in the day, you know, you can see individual things on the bottom of this crater, but back in the day, you know, Area crater was just a crater, approximately it was near the equator as well. You can see the Latin long, whereas although its actual coordinates now are slightly off from true 0, 0. Pardon? What season? Oh, so I got you.
Are you asking a question?
She is. So
Please wait to ask questions in the microphone.
right. So I don't know where the microphone is, but we'll get up here. I'll repeat the question. So the question was, so unlike some planets in the solar system, Mars, like the Earth, has dynamic seasons, and the polar cap grows and shrinks with those seasons. Now, I've avoided the polar caps because polar caps are kind of ugly. Let me zoom into them, and you can see that it's kind of ugly, and you'll say, Ross, why are the polar caps kind of ugly? And the answer is it has to do with the way that Google Earth maps the imagery data at the poles. What Google Earth does is it takes a big rectangular map of data, of pixels, and then wraps them around the top of the globe. And of course, if you do that, it looks bad at the top of the globe. And so that's what we're encountering here. And so there's, and of course, it's like that because apparently no one on the Earth cares about the poles. So it's a historical decision that the Google engineers made years ago when they first built this. And there's some impetus to try and get that changed and get a better imagery projection at the pole so it doesn't look quite so poor. But to get back to your question, which was how do you choose what time of year are you showing for the poles? And the answer is we didn't choose. We just took whatever data was available. And so as you can see, the background data is MDIM. As I said, it's MDIM data from Global Viking imagery. It's colorized by Mach wide angle. And I don't know what the seasonal constraints were on the MDIM data. The higher resolution, although you couldn't tell it from here, the higher resolution strips like this one, which are the HRSC data, are from whenever they were taken. So probably will be a different season than the background imagery. Now, one of the things that I will give in our defense for the polar data, let me turn off, no, I can leave those on. Oh, no, I can't. So some of these, we recognize that the poles just are bad. And so for some of these polar images, we actually provided an overlay that you can load. Let me see if this one has one. Yeah. So just like, not all. So just like with the CTX image, right? So if I zoom into this, this looks bad. It looks bad. That's a high resolution image. It's beautiful. It looks bad. So what we did is we, through some magic, one of my colleagues managed by basically faking out the projection information, we can paste in a better resolution version, and you can, it's a little better quality. Yes. Sorry.
Is there a way to interact with the data on here in sort of an automated fashion? For instance, by searching for all photographs, say, that match certain elevation data or slope data, and then use that sort of in an automated way?
Yeah, that would be cool.
Right, so not just grandma.
No, you can't do that via this client. So that really gets on to the edge of real geographic information system technology, things like products like ArcMap and ArcInfo. As far as we can tell, Google is not interested in building a full-featured geographic information system. This is really a tool for the public. So you can't make those kind of complicated queries about the data in Google Earth. It would be cool if you could, but you cannot.
This is just a question about technology. Are you actually sending pixels, or is everything being converted to vector format before you display it?
I can only answer that partially because I don't know for sure. These are pixels. So let's see. So the polygons. So it's a mix is the answer. So when you see things that are polygons like this circle or the red boundaries around the edges, that's vector data that's being sent and rendered by the client. The imagery are actually pixels that are being sent in a tiled format and rendered locally. And then when I tilt this view, the client itself is doing the reprojection and the foreshortening on the pixels themselves.
Okay, we are almost meeting by Mars, but this is the question that we're expecting, I'm sure. So what will be the next planet?
I can't tell you what the next planet will be. You may be able to guess. Could be the moon. NASA is sending a spacecraft to the moon later this summer.
No,
Titan? Titan would look like an orange fuzzy ball at any resolution. Right? So the problem, we've run into this problem a little bit, is that, Titan would look great kind of at this level, or maybe even at this level. But if you go all the way in, Titan will just look fuzzy. So one of our kind of uphill battles with Google is, Google's like, but this isn't for scientists. This is for the public. And if they zoom in and see fuzz, they won't know what to do with that. They won't really know maybe what that means. So I think that there is a good case for getting additional data sets. And in the meantime, you can do things. We can do things like this, like my my IO trick, where you cover whatever planet in IO, or you cover whatever planet in whatever global base map, and you can put in individual overlays, and you can serve this data from your own private servers or team servers or whatever. It's just not, there just isn't a nice handy pull down button at the top that says go to Titan. Maybe there will be one day. We'll get enough data and we'll be able to make the case to Google to add it in.
Hey, Ross, was the NASA whirlwind effort
Folded into this endeavor, or is that
No, so
because they had Venus on there?
they do, yeah, and it's awesome. No, there are a lot of strange camps at NASA, and NASA Whirlwind. The developers for that are now, there's been some strange rearrangements, and there's strange political issues in that part of NASA that I can't claim to understand. Their developers are now talking with the developers at Ames that worked on this with me, Matt Hancher and Michael Broxton, which are excellent developers. I was mostly just the science advisor to this project. I refer to myself as the Mr. Spock to their Jim Scotties. Yeah, that data hasn't been folded in and is actually provided in a fundamentally different way. Yeah.
Can you explain the data?
Excuse me?
Can you explain what whirlwind is?
Oh, so Whirlwind, Whirlwind has a couple of different instances, so to speak. So there's a Whirlwind program that's a lot like Google Earth. It's for Windows only, and it's built on Java. And you can explore the Earth, you can explore Mars, you can explore Venus. And it has more kind of science-y functions. It's more on the way towards being a GIS, certainly, than Google Earth is. But one of its big problems is that as an application, it was kind of Windows only. And that kind of closed down for a lot of people. There's another instance, it's not the right word, there's another kind of thing that Java Whirlwind does, and that is they also provide what's called a software development kit. So, which is kind of a more basic thing where if you're writing a viewer like Google Earth, or in fact, actually guys at Goddard Space Flight Center that are trying to build a GIS for the moon are using Java Whirlwind technology, using this kind of Java SDK to build a globe viewer for the moon, and you can do that in any platform. So originally Java Whirlwind was this standalone application. It was something you would run as a user. And now its development has kind of gone away from that. They're really developing this kind of core tool set that other people can use to incorporate into their programs. And that seems to be more the way that that's going now.
Okay, so last question.
But while the microphone gets on, I'll say I'm happy to answer any other questions you have afterwards. But yeah.
You mentioned that this is one of many tools that your scientists use to analyze data. And I guess maybe this is a follow-on to this Whirlwind question, but do you envision having a version of your own version of, or emergence or versions of Google Earth, or Google Mars, or Google Earth-like tools that are fully functional, that have access to the data, the actual data, you can get the images right back, and the interaction between analysis tools and exploration tools, do you see that coming?
Yes. And I hope it comes faster.
Is that going to come, apparently it's not going to come through Google.
No, it probably won't.
So, but you're not familiar with groups. I mean, it sounds like the Whirlwind thing is, I guess that's the closest thing. There's a toolkit, and they let other,
That's right.
any given group. But there's not what it's like sort of open.
No, there's not a complete clone of Google Earth that's open and has more features. Yeah. No. So one of the advantages is that a lot of teams are now providing their data in more kind of standard data stream formats. There are standards for providing map imagery data and vector-based kind of positional data so that any browser can read that data. So Whirlwind as a browser, Google Earth, ArcGIS can all open and operate on these things that are called web map servers or web feature services. And so in the future, it'll work a lot more like the web does now, where data providers have a server that serves the data, and you can come with whatever browser, whether it's Safari or Internet Explorer or Firefox, and read that same data into your geo browser instead of into your text browser. I think that's a lot of technologies are kind of moving in that direction.
All right, well, let's thank everyone.
Everyone, let's thank Ross for a great talk. And